We were at 70 last time I looked. I think we're probably done. Everybody get it? Let's see here. I have 89 people have responded. I should have paid closer attention to how many people attended. That would have given me a sense of where I should stop here, you know? I got 90 people responded. I think, is it closed? Has it closed? Okay. All right, so we had 33 people. 33 of you thought that the number of whole numbers is less than the number of natural numbers, is less than the number of integers, is less than the number of rational numbers. And I must agree with you. That's what I would have thought, like when I first came to this question. It is surprising to me, and I don't think it's at all obvious, but it is true that in fact the size of these sets are all equal. It's true. And you're like, what? How can you make a one-to-one correspondence between counting numbers and fractions? Yeah? No, I don't want that. Second here. So let me show you. So it's fairly obvious how to make the one-to-one correspondence between n and w. To get from natural numbers to whole numbers, you just subtract 1. And that's a one-to-one correspondence. Send 1 to 0, send 2 to 1, send 3 to 2, like that. That's the one-to-one correspondence. For integers, it's trickier. But for rational numbers, this is something that Cantor did. That's why I mentioned Cantor. He suggested that you could take the set of all fractions, lay them out in a grid, and like every fraction you can reduce to lowest terms, like cancel out any like terms. Like for example, what is 3/6? It's 1/2, right? So keep the 1/2, ignore the 3/6, just look at fractions in their lowest terms. You can make a grid of them like this, and his one-to-one correspondence is to follow the grid with like, come on. A snake. This is Cantor's snake. Come on. See that? And that's the correspondence between natural numbers and fractions. I would never have thought of this in a billion years, but Cantor thought of this, and ever since this, we have known that the size of the natural numbers and the size of the rational numbers are the same. In contrast, the size of the real numbers are not. The size of the real numbers are bigger. The real numbers are as big as the power set of the natural numbers. This is called the continuum. But anyway, if you want to learn more about that, come take the Foundations of Math class that we offer here. Math 200, I believe. We'll talk about it in there maybe. Anyway, have a good weekend, you guys. I hope that's enough for you to do the homework.